So, very good morning to all of you. In today's class, we are going to discuss about our next topic, that is normalization. In the last class, we have seen that how to find out the keys, a different type of keys, super key, candidate key, and primary key. Now, that those things are going to help for this particular topic, that is called normalization. So, first of all, what normalization is? Normalization is a process of decomposing unsatisfactory. First, I will write the definition, then I will explain you. Unsatisfactory, or we can also call it as bad relations, by breaking their attributes into, by breaking up their attributes into smaller relations while ensuring while ensuring data integrity, while ensuring while ensuring data integrity, comma, eliminating data redundancy, and minimizing the insertion, comma, deletion, and updation anomalies. This is the definition of normalization. So what exactly we are going to do in normalization? First of all, we have to understand some term. What is the term? Terminology we are using is unsatisfactory or bad relation. What is the meaning of unsatisfactory or bad relation? Relation, you know, it is a table. Table consists of rows and columns. Now, a table, we will call it as unsatisfactory or bad relations if in that relation you are getting the redundant data, means repeatedly the data is used. If it is the case, we will call that particular table as a bad table or unsatisfactory table. So in that case, what you have to do, in that case you need to break the table, means single table. For example, the table is R1. Suppose that R1 is unsatisfactory, or we can call it as bad relation. I told you what is the meaning of this bad relation or unsatisfactory relation. For some of the columns, you might be getting the redundant data. And also you may have some of the column values null, means no data will be there. So you know that to find out a particular key attribute, for every attribute, you should have some value. That's the reason you can find out something. If nothing is there, if blank is there, then how you can find out the things? The concept is very simple. The data should be there. Very important. Second thing is that the data should not be repeated. If it is so, you will tell your relation is bad relation. So what you have to do? You need to break that table. So ultimately breaking table means what? Suppose this table is having 5 attributes A, B, C, D, and E. Breaking of table means what? This R1 you need to convert into 2 more tables, where you need to keep in mind the attribute should not be missing. Means it doesn't mean you are breaking in a way and you are skipping some of the attributes. No, it is not like that. You are breaking in the way, for example, you are breaking in two table R11 and R12. R1 is decomposed into two tables. One is R11, another is R12. In R1, for example, you are having the attributes A, B, C. Then what is left? DE is left. So you will write in another table DE. But how you can combine these two tables? Means again you should have any one attribute common, so that you can, when you are going to merge again R11 and R2, you will get the actual R1. Otherwise, it will not be possible, because I told you two tables, if it is not combined, then you cannot form one table. So for that, I already told you, you should have at least one attribute common in both the attribute. Let us take that attribute is A. So in that way, you need to break this particular R1 into two tables, R11 and R12. R11 consists of ABC and R12 consists of ADE. This is for example. Okay. Now, while ensuring data integrity, means data should be there. It doesn't mean that data should be lost. No, data should be there. Means whatever the data is entered into the main relation, it should also be there available in that. So data integrity should be there, comma, eliminating data redundancy. Now, if you will going to see these two table, some of the repeated records which were there, now it is what? Segregated in two different tables. So you will find the case that the redundancy will be eliminated, and and minimizing the insertion, deletion, and updation anomalies. Now, these three terminology we need to understand. So what is the meaning of this normalization? You have some unsatisfactory relation, means some redundant data will be there, some empty fields will be there, which is not at all accepted. If it is so, you will say that relation is in bad form or unsatisfactory form. In that case, you need to go for normalization process. Means you break this particular table which consists of attributes. So ultimately the meaning of breaking a table means what? You are going to segregate these attributes of your parent table into two child table, which is coming from parent table only, provided you are ensuring that when you are breaking this original table into two of table, data integrity should be there, means data should not be lost. Second thing is that you should be able to remove the redundancy, means whatever the repeated records were there, you need to remove it. And the third one is minimizing the insertion, deletion, and updation anomalies. These three things we are going to understand with one example. So up to this we have done. So this is what the definition of normalization. So simple definition, it says it is a systematic process of reducing the redundancy. Simple definition is what? It is a systematic process of reducing the redundancy and avoiding the existing anomalies. Whenever we are talking about existing anomalies, you may have three types of anomalies. Anomalies is nothing but you consider it as a problem. Three kind of problem can be there. One can be insertion related problem, second can be deletion related problem, and third can be updation related problem. Okay, so these things we are going to avoid. So it is a systematic process of reducing the redundancy and avoiding the existing anomalies available in the relation by breaking the relation into two further relations. Now we will understand what is the meaning of insertion, deletion, and updation anomaly. For example, we have a table employee information. In that, the fields are employee ID, employee name, employee address and employee department. Some values are there, for example, 101, 102, 103, 104. Name is suppose A, B, C. Address is Delhi, Hyderabad, Chennai, Mumbai. Department, you can say anything. Okay, suppose they are working in D001, D002, D002, D003. Okay. Now we will try to understand the concept of what insertion anomaly first. Insertion anomaly. Now suppose, let us take a case. Suppose a new employee joined. In the company. Okay. But not assigned to any department, because he or she may be going for training. Okay. Just try to understand the concept. New employee joined into the company. Suppose after some time, some of you will be going to select in some of the companies. Then when you're going to be selected, at the same time, they are not going to give you the post that you will be the software engineer, or you will be the hardware engineer, or you will be in a maintenance personnel, or whatever the fields will be there. They are not going to give you the post directly at the time of selection. Once you will join the company, they will give training to you, and after that they will go for assessment. Assessment means what? They are going to conduct some tests based on training. Whatever they are going to give you, they are going to conduct the test, and in the test, according to your performance, they will evaluate where you will be going to fit. If you're going to fit into some of the fields, then directly they will nominate you and they will offer you, okay, now you will be the employee of this company, provided we are willing to give you this particular field. Now are you ready to go for it? They are giving you further choice. So don't think that once you are selected any particular company means what, from the day only you will be uh, relaxed that now I have got a job. No, after 2 months of training, if they will found that you are not at all suitable, they will kick you. They will tell you that you leave the job. It is not like that first day they will give you a bond. No, they will take a bond from you. If you will be suitable, then you have to work for at least 2 years, 3 years, whatever it is. So it may be a different issue. The thing is that the new person, when he or she joined, they will not be getting their department. So in that case, if a new employee will be added, we can get the name of the employee, we can get the address of the employee, but we cannot get the department. So at that time, what will happen? This particular employee department, we need to make it blank. We need to make it null. This problem is called insertion anomaly. I hope you understand. Now, come to the second one. Second is called deletion anomaly. Now, suppose you want to delete record from the table employee info where the name of the employee is A. Just think the situation. Again, you need to look into this table entry. And once you will look into this table entry, you will find that they ask you to delete the records related to the employee name A. But if I will do so, what will happen? Maybe I want that this A should be removed. But if you are going to remove A, this A is coming twice. And if you are going to remove the record related to the employee name A, it means what? Two records will be deleted which are not dependent on each other. They both are separate records. One is another person, another is another person. But if you are going to remove the records based on the name, again the problem will be there, that the two records or whatever the matching number of records will be there, they are going to be deleted. So it should not happen. That is what called deletion anomaly. So you need to delete the records appropriately so that the other records should not be affected. That is called what? Deletion anomaly. If you are not looking at the particular parameter at the time of deletion of the record, then the entire records related to that particular employee name will be deleted. So that is the second problem called deletion anomaly. And the third one is called updation anomaly. With the same example, we can say updation anomaly. Again, if we are going to ask you to change the address of the employee named A, address of the employee name A. If we are going to change the address of employee name A to, for example, they are going to give you Pune. What will happen in that case? In that case, two records will be going to affected. One is Delhi will be going to change to Pune, and another time Hyderabad is again going to change to Pune. But again, the question is same. Are they both same person? No, they both are different person. It means if you are going to update it, again the update should be for a specific record, not for the matching records. Exact. What will happen in that case? You will be going to change the other value which is not related to the first. So that is called the third anomaly, called updation anomaly. Similarly, you may have another cases. You are having multiple tables. Here we are talking about single table, but you are working in the database, and you know that in the database you will be having multiple tables. Means the same record will be reflected in many other tables also. So if you are going to make the change in one table, then what about the other tables? Why that same thing has not been changed into the another table if the record are same? It is related to the same person. So what is the meaning of this? If you are going to make the changes, it should be reflected to all the places, not into the single table. Otherwise, what will happen? The problem will arise. We are searching something and we are not getting the records, and even though we'll say no, they are existing. So there is a kind of mismatching the records. So this is called what? Updation anomaly. So I hope you got all these three types of problems. So to avoid or to remove or to reduce, we cannot say that anomaly we can totally remove, but anomaly we can reduce. Normalization never say you are going to remove everything, whatever the problem is there. No, the general concept of normalization says that somehow you should be able to reduce it. Whatever the problems are there into the bad relation, you should be able to reduce those particular problems by decomposing it or by applying some systematic process or approaches, so that these kind of problems can be reduced up to some level. That is called normalization. Now come to types of normalization. So we'll start with first normal form. We call it as 1NF, called as first normal form. Okay. Now what first normal form says? That is the important thing we have to understand. Now first normal form says, or is it states that the value of any attribute, the value of any attribute in any table or any relation must be a single atomic value. A single atomic value means what? In short, no attribute in a relation should be multi-valued. This is the summary of this statement. So relation will be there, then attributes will be there, then values will be there. If the values will be there, there is a possibility that for some of the attributes you may get the multiple values, which is called multi-valued attribute. Means more than one value will be there for that particular attribute. For simple example, you have a relation called again student with student roll number, student name, student contact number, and gender, whatever it can be. Roll number will be unique, for example, 101, 102, 103. Name may be repeated, Ram, Ram, Mohan. Contact is, for example, 1, 2, 3, 3, 4, 5, 2, 4, 5, 6, 7, 8. We are writing in rough. Okay. Gender is obviously one gender will be there. Okay. Now, if I will tell you whether this particular relation is in the first normal form, normally the question will be asked like that. What is first normal form? Explain it with a suitable example. So you need to write the definition of a normal form, first normal form. So first normal form says that all the attributes in a relation should be a single or atomic attribute, means no attribute in a relation should be multi-valued. The summary of that is, now you will go with all the attributes and you will try to find out, is there any attribute which is having multiple value? You will find, yes, there is one attribute called contact. Here you are getting two values for contact number. For others, it may be single, but for some, you will be getting 2, 3, 4. It may be the case. So you will say that no, this relation is not in first normal form. This is not in first normal form. Now, if it is not in first normal form, then what you have to do? You need to convert into first normal form. So what you have to do? Here in the first normal form, you need not to decompose the relation. Decomposition starts from second normal form. Here what you have to do is, you need to remove this multi-valued attribute by repeating this particular row one more time, where one time you will be introducing this value and another time you will be introducing this value. So what will be going to happen in the next case? Now convert into first normal form. Okay, so what you will do, again you will write the name of the table, the fields, student roll number, student's name, student contact, and gender. All is male. Student roll number is 101. Next is, again I'm writing 101. Next I'm writing 102. And next I'm writing 103. So this time you can see that my one row is going to increase. Earlier it was only 3 rows. But just to avoid this particular problem, which is existing for contact number, here the contact number field is containing two values, which is not acceptable for first normal form. So you need to convert the bad relation into first normal form by repeating this particular row. Provided one time you will keep the value for contact number 1, 2, 3, and another time you are going to keep the contact number 3, 4, 5. So what exactly we are going to do? Here It will be Ram. It will be Ram. It will also be Ram. It is Mohan. Now, one time you will write 1, 2, 3. Next time you will write 3, 4, 5. 1, 2, 3, 3, 4, 5. 2, 4, 5, and 6, 7, 8. 2, 4, 5, and 6, 7, 8. But we cannot say that here the records are repeated. No, here records are not repeated. Repetition means what? Same value, exactly same value for all the row is repeated. Then only we can call it as repeated. But here 101 is containing 1, 2, 3. Another time 101 is containing 3, 4, 5. So these are belong to the same person. That is okay. But we have removed the problem. Now this particular relation is in first normal form. Now the above relation is in first normal form. Okay. So one time you have kept 1, 2, 3. Next time you have kept 3, 4, 5. So in that case, what was the problem for first normal form? You have removed and you have converted the relation into first normal form. So this is what called as first normal form. Now come to the next normal form, that is called second normal form. 2NF. We call it as second normal form. In short, we call it as no partial dependency. Okay, now what second normal form says? So you need to write the statement. The relation is said to be in second normal form if it satisfies following conditions. It satisfied following conditions. Now, what are the two conditions are there? First, if you're asking you that the relation is in second normal form or not, then the first thing what you have to check it that the relation should be in first normal form, first of all. Means the summary says whenever you're going for the next level of normal form, then it is expected the first condition, always it is expecting the first condition that the relation should be normalized up to its lower level normal form. What is the meaning of this? If I'm asking about second normal form, then it is expecting that first of all your relation should be converted up to first normal form. Then the actual use of second normal form or the actual concept of second normal form is going to initiate with what? B part, second condition. Now, what second normal form says that the table should be in the first normal form, and second is says no non-prime attribute, no non-prime attribute is dependent on proper subset of any candidate key, any candidate key of the table, of the table. What it says? First, it expects that your relation should be normalized up to first normal form. So we are expecting when we are talking about second normal form, our relation is by default converted up to first normal form. If it is not so, then first of all, you need to convert into first normal form. Then only you can go to the next level. Now come to the second level. Second level says that, or second normal form now says that now my table is in first normal form. Now what next I have to check? The next thing what I have to check is no non-prime attribute. Now one new terminology introduced here. No non-prime attribute. So first of all, you should be able to know what is prime attribute, what is non-prime attribute. What is prime attribute and what is non-prime attribute. So first, no non-prime attribute is dependent, means no non-prime attribute should be derived on proper subset of any candidate key of the table. What does it means? There should not be having any partial dependency. The meaning of second statement is that there should not be, means no non-prime attribute should be partial dependent on candidate key. It should be fully dependent, not partial dependent. That is the concept we need to understand. So let's go to this. Suppose we have a relation R with the attributes A, B, and C. Okay, we have the relation R with the attributes A, B, C, and for example, your B can determine C. This is given to you. Means what is given to you? Functional dependency is given to you. That is only what B can determine C. B can determine C. Now, what is the second case? No non-prime attribute is dependent on proper subset of any candidate key, or no non-prime attribute should be partially dependent on candidate key. It should be fully dependent on candidate key. So first of all, these two terminologies coming, non-prime attribute, and the second is coming is that is candidate key. That is candidate key. So if I will ask you, find candidate key, you need to find what? Candidate key. And I told you the approach, how to find out the key attribute if the functional dependency is given to you. So what is the thing missing into the right hand side? The things out of A, B, C, what is missing in this right hand side? A is not available into the right hand side, B is not available into the right hand side. So the missing element or attributes in right hand side of functional dependency is A and B. These two. You can see this is RHS, right hand side. This is LHS, left hand side. In the right hand side, only C is available out of A, B, C. What is missing? A and B. So if you are asking you to find out any attribute, any key attribute, then you need to start searching from the element which is not available into the right hand side, and you need to combine. Means A alone cannot generate all the attributes. Similarly, B alone cannot generate. It requires the combination. So take the closure of AB. Take the closure of AB, which is what? AB plus. So if you'll take the AB plus, with AB you can generate AB itself, and with B alone you can generate C. What is the meaning of this? AB is candidate key. Means what? Alone A is not a key, alone B is not a key. Combination of AB is a candidate key. I hope you are understanding. Now, if you will go with this, you have found C is derived by B alone. But you are telling that B is not a candidate key. AB is a candidate key. Not alone A, not alone B is a candidate key. Now come to the question. No non-prime attribute. Now come to the concept first. What is prime attribute and non-prime attribute? First is prime attribute. Now what attribute is called as prime attribute? The attribute which is a part of any candidate key. Why I'm writing any candidate key? Because I told you in the previous class you may have more than one candidate key, but here only one candidate key you are getting. But if suppose you'll be getting more than one candidate key, then you need to check in every candidate key. What you have to check? The attribute which is a part of any candidate key is called prime attribute. Is called prime attribute. So here in this case, what are the prime attribute you have? The prime attributes here in this case is A and B. Two attributes will be called prime attribute. Now, what is non-prime attribute? Just the reverse of this. Non-prime attribute. So, the attribute which is not a part of any candidate key. Here, what is that? C. So C, you can see out of A, B, C is called a non-prime attribute. Why we are calling it as a non-prime attribute? Because C is not a member of prime attribute, not a member of candidate key. So candidate key is only one, A, B. So you will check in A, B. A will also be a prime attribute. B will also be a prime attribute. What will be C? C will be a non-prime attribute because C is not a part of AB. C is not a part of AB. Now, come to the definition once again. No non-prime attribute. Here you see. C is a non-prime attribute. No non-prime attribute is dependent on proper subset of any candidate key. Proper subset means what? A and B. Now, once you'll go with this, you will find in the definition C, which is a non-prime attribute, it is partially dependent on B, which is not a candidate key. I'm repeating, C is a non-prime attribute and it is partially dependent on subset of candidate key. Means what? AB is a candidate key, B is not a candidate key, but B is a prime attribute. So non-prime attribute C is partially dependent on B, which is not correct. So my question is the relation in second normal form? The answer is no. The relation is not in second normal form. So we'll go with this. Again, R with A, B, C, and we have generated that B can derive C, and we have proved what we have proved, that AB is prime attribute and C is non-prime attribute. And here non-prime attribute C is partially dependent, which is not accepted. Partially dependent on B, which is means B is not a candidate key. So relation is not in second normal form. You need to decide if this particular question will be given to you and they will ask you whether the relation is in second normal form or not. Then you have to go with this concept. You have found functional dependency given B can determine C. You have found the key attribute, which is what? AB, which is my key attribute also, which is my candidate key also. And A and B both are separately prime attributes also. C is not a member of AB. That's the reason C is a non-prime attribute. Now, the statement says that no non-prime attribute, but here one non-prime attribute is depend on partial, which is nothing but the subset of a candidate key. So B is a subset of candidate key, AB. So C is not fully dependent on AB. C is partially dependent on B. Getting my point? It should be fully dependent. So if it is not so, then what you have to do? So what to do? So convert or break or decompose relation R into R1 and R2. Now we are going to convert R. What is R? R is A, comma B, comma C. Now we are going to generate R1 and R2. We are going to decompose it. How we are going to decompose it? Once you will be going to decompose it, now it will be called two relations. And in the two relations, the keys will be different. So here, who is taking the initiative that I alone can determine C? B is taking initiative that I alone can determine C. I do not require the help of A. You can see here it is directly given. I am not telling it is done. In the question itself, it is given. B is taking the initiative that I alone can determine C. I do not require the help of A here. So if he is going to become a minister, let him be a minister. Let it be. If it is so, then who is going to take initiative? You make that particular attribute in another table. You make that attribute in another table. So what I'm going to do, I am going to make a relation here. Only two attributes will be there. What are the two attributes? B can determine C. So two attributes now come here. Who is missing here? So keep in mind, whenever you are decomposing, your first relation should always contain candidate key. Should always contain candidate key. If I'm saying like this, what does it mean? It means you are directly understanding, then R1 should contain candidate key. It means R1 should have A and B. R1 should have A and B, and here you will be having only B and C. So in this way, you have decomposed this relation R into R1 and R2, where keep in mind, whenever you're decomposing, always in the first table, you keep the candidate key attributes. So we have kept AB, candidate key attributes. And in the second table, what are the things they are claiming that I alone can do? So better if you alone can do, you do in another table. You don't do here. Now what will happen in that case? In that first table, R1, you will be having only attributes A and B, and whatever records will be there, you will be getting that, because we are not talking about the records here. And R2 will be having the attributes B and C. R2 will be having the attributes B and C, where B is helping you to combine these two tables. Where B is going to help you to combine these two tables. So this is how we have removed that partial dependency exists in a relation by decomposing into two relations. In the way we have reduced the redundancy. So here we have not kept the data. If you can keep the data, then we have to work with the data also. Means we have to keep the records also here, like that. And in that case, you will come to know that redundancy will also be removed. So this is what the concept of second normal form. Okay. Now come to the third normal form. We will see the theory part. Explanation we will do in the next class. So next is third normal form, 3NF. Third normal form. So as I already told you, when we are going to the next level of normalization process, we are expecting that before going to that level, first of all, we are expecting that our table is by default normalized up to the previous level of normalization form. Means we are talking about 3NF. So a relation is said to be in third normal form if it satisfies the following two conditions. Following two conditions. And this is also called as no transitivity dependency. You know what is this? No transitive dependency. Okay, you know what is the meaning of transitivity dependency. So if transitivity dependency you will see, then you will say that your relation is not in the third normal form. No transitivity dependency should be there in your table. Then only we can say that our table is in third normal form. This is the just a one line concept to understand what is third normal form. Similarly, one line concept to understand second normal form, that no partial dependency. Similarly, the first normal form says that no multi-valued attributes. I hope you are understanding. First normal form says that no multi-valued attributes. Second normal form says that no partial dependency. Third normal form says that no transitivity dependency or no transitive dependency. So a relation is said to be in the third normal form if it satisfies the following two conditions. First, the relation is in second normal form. The relation is in second normal form. And the next thing is that transitive functional dependency. Transitive functional dependency of non-prime attribute of non-prime attribute on any super key on any super key should be removed. Should be removed. This second condition we can summarize. This second condition we are going to summarize. For example, for each functional dependency, for example, X can determine Y, then at least one of the following condition should hold. Now, what is the condition? Either X is super key or second case is Y is prime attribute. X is a super key means whatever functional dependency you will be getting, if you're getting that, then your X should be a super key, or else if X is not a super key, not matter, your Y should be a prime attribute. Then you will say that your table is in a third normal form. If either of these two conditions will be there, then you will say that your relation is in a third normal form. Or for simplicity, as I told you that I told you that in that particular case, no non-prime attribute means, again you have to find out prime attribute, non-prime attribute. You need to find out the super key. So no non-prime attribute should be no non-prime transitive functional dependency of non-prime attribute of any super key should be removed. Means they should not be dependent on that. They should not be dependent on that. If it is the case, then only we can say that our relation is in the third normal form. So this thing we are going to discuss into our next class. Okay. So thank you one and all for attending today's class.